there and welcome to my brand new series on physics. This series will be looking at the very amazing ideas and theories discovered in physics and how they were stumbled upon and what implications they may have. So what I'd like to start today is with the EPR experiment, and I'll start off by introducing the thought behind it. The EPR experiment was conducted in 1935 by Albert Einstein, Boris Podolsky and Nathan Rosen. The experiment was designed to disprove quantum mechanics and destroy the idea of probability it contained, as these three giants of physics found it remarkably stupid that the universe was governed by probability. So the idea of the process was as follows. So if we take two electrons, let's say, and we'll call this one here electron 1, and we'll call this one here electron 2. And we check what are the vibrations and how this electron is vibrating. And what you find is electron 1 is vibrating as this, and electron 2 is vibrating like this. And if we match these two together, or using special equipment, we can get the two electrons to vibrate together. So they both have exactly the same vibration pattern. And this is called coherence. It's coherence. And this is when two electrons are vibrating in unison. And what this means is, if I take these electrons that are vibrating in coherence, and let's say I put it here, and then we can say, oh, there's some sort of wave pattern that connects these two electrons together, then I can separate these two electrons at any distance. Let's say the separation between them two is an infinite distance or an X amount of distance. Then they will still be vibrating in unison. That does not change. And as that does not change, they are some way entangled. And this is called quantum entanglement. So quantum entanglement is a Schrodinger wave that connects the two particles together. And a Schrodinger wave is a wave of probability. Probability in many senses, even in the particles' energy, its momentum, its velocity, its position. It could be anything. So a very simple one could be something as follows, where this is position A and position B, and the particle's most probable value is over here. This is the most probable place to find the particle. But that means it could also be found anywhere at any of these positions, but the most probable will be here. So this wave of probability connects the two particles together, and therefore that means if anything happens, let's say to electron 1, then information is instantaneously transferred to electron 2 due to this quantum entanglement. And this has many implications, and I'll show that to you now. So let's say we take another two electrons again, and we synchronize them as the ones before. So we say that this is electron 1, and we will say, we'll say that this is electron 2. And these are synced, so they are beating in unison. They have the same Schrodinger wave pattern. I then take, let's say, electron 1, and I observe it alongside electron 2 to check for the total spin of the system. And basically what that means is one electron spinning the other clockwise, or is one electron spinning anti-clockwise? And what I'll find out is, while I make that measurement, I find out that, okay, that electron is spinning anti-clockwise, or it's spinning clockwise, and the same goes for the other one. I find that this is spinning anti-clockwise, or it's spinning clockwise. So I can say that the total spin of the system, it has to be equal to 0, because either one electron is spinning clockwise and the other one has to be spinning anti-clockwise. They can't be both spinning clockwise. So if I then say I take my two synchronized electrons and I keep the yellow one in the lab, and I then send the blue one off at 2 million light years away, let's say. So let's just draw a little thing here, and we can say that is a separation of 2 million light years. And then we say, okay, so we either know that this one is spinning anti-clockwise or it's spinning clockwise, and this one here is spinning anti-clockwise or it's spinning clockwise. And we then take an observation, so let's say. So we know that they're either one is spinning the other way, or the other one has to be spinning the opposite. As we said, the total system has to be 0. So we then take the one that we kept in the lab, the yellow one, and we look at that closely and we make an observation on that. And then we say, okay, we found out, okay, that this electron is spinning anti-clockwise. Instantaneously, as we know the total system's spin has to be 0, the blue one's spin must be in the clockwise direction. That is a instantaneous decision, or instantaneous fact that we have learned just from observing an electron, which are separated by 2 million light years. And this information that is being transferred from this electron all the way to the blue one to tell it, okay, I have become a anti-clockwise spinning electron, that means you need to become a clockwise spinning electron, happens faster than light. Faster than light. And as you can see, this fact that the information has traveled faster than light would have upset Einstein, as his whole theory of relativity was based on the fact that nothing travels faster than light. So how can some information from this electron all the way to this electron occur faster than light? And he basically called it spooky action at distance. He did not like it. He did not like the idea that it was happening faster than light. So from this, he concluded that quantum mechanics is false. It cannot be true, as nothing can travel faster than light. But in France, in 1980, from a physicist named Alain Aspect, they done an experiment using photons, and I'll show you that now. So the experiment that they did in France was basically a similar idea to what this was about, and it used calcium atoms. So if we say that this is a calcium atom, and it used the photons that were emitted from this, and before they know what is the spin of the photon, the same way the electron has a spin, the photon also has a spin. They knew that they would at least be in sync. So by taking two or more photons, so let's say we use this photon here and this one here, they measured the spin of one of them and used that to find out information on this one here. And what they found was, instantaneously, even when the photons were 13 meters apart, the information was travelled faster than light to the other photon. So basically, the other photon changed its spin according to the observation made on this one. So this is the photon that we looked at. This is the photon that was being its counterpart. The spin on this one was the one that was measured, and the spin on this one was the one that was basically discovered from the information on this one. And this fit perfectly with the quantum theory. And this the experiment is very similar to the EPR experiment, but the information therefore did travel faster than light. But how can this be when relativity says it can't travel faster than light? Well, the information was random. The information had no meaning to it. You couldn't send anything valuable through this process. It was totally random. The information that was sent was random. By knowing the spin of one photon you could not send the information to the other side of the universe of the other photon. Let's say we had a electron here, and its spin was this way. We found out it was this way, and its counterpart was on. Let's say this was on the planet Earth, so this was Earth, and its counterpart was on another planet over here, where there was a group of people working, and this electron here had a spin going this way, because we observed that this electron had a spin going that way, so this one becomes that way. Well, by knowing the spin of this electron, the people over here, so the people over here, well, no valuable information is gained from observing that electron, and it seems more as if it was a conscious decision. And basically, yeah, this is the idea of the EPR experiment, and it has amazing implications on quantum teleportation, where physicists have actually teleported. First they teleported smaller particles, and then they actually teleported larger atoms, and I'll go through that on my next video. So thank you for watching. I hope you enjoyed the video. Please like and subscribe to the video, and why don't you check out the other two videos here I've posted on the page, for Minute Physics and 60 Symbols. They're both brilliant videos on explaining many different and very cool topics in physics and some mathematics stuff. So thank you for watching, and I will hope to see you again. Bye.